Hello, my name is Ayman Ahmed. Today we're going to go over VLSM, which is the Variable Length Subnet Mask. And in the previous lecture, we went over regular subnetting. And regular subnetting uses a fixed length subnet mask. Like we used to find out the magic number. Like say here, for example, here we have 1, 2, 4, 1, 2, 4, 8, 16, 32, 64, and 128. What we used to do is just to find the magic number. Like say if we are looking for 10 users, that's our magic number is 16, right? That's for 10 users. Our magic number is 16, and then our subnet mask would be 128 plus 64 plus 32 plus 16, which is 240, right? So that would be the fixed length subnet mask. But today we're going to talk about variable length. So, and in the fixed length, what we used to do is after we find the magic number, for example, at this one, then we do just the increment. Start from 0, 16, 16 plus 16 is 32, plus 16 is 48, and we go on. You see here, from 0 to 16, we have 14 hosts, which is from 1 to 14. From 1 to 14. 15 is the broadcast IP. So today we're going to talk about VLSM. Okay, VLSM, that's a variable length. So it's not necessary to be increment of 16, right? 0, 16 plus 16 plus 16 plus 16 in this case. So it can be different length. That's why they call it variable length subnet mask. So here in this network, we have the green network require us, first of all, they gave us this here, this IP, this block, this IP number 192.168.10.0/24, and they ask us to subnet it, and they have their requirement, the number of users. So here in this green network, they have 12 users. In the red networks here, in the network here, they have 50 users, and in the yellow network, they have 30 users. And don't forget those ones. Those are point-to-point links. They have 2 IPs, one for here and one for here. And again, here also they're point-to-point. They require 2 IPs, and here also 2 IPs. So that's variable length subnet mask. So let's here just remember this one here, 12 users, 50 users, and 30 users. When you do VLSM, remember to start from the largest number of users. So our largest number of users here, we have 50, and also we have the second largest 30, and the third largest 12. Those are 12 users, and then 2 and here for those ones 2 and 2 and 2. So we have 2 and 2 and 2. So it's required 2 IPs here. So we have 1, 2, 3, 4, 5, 6. So we have this network, this IP address, and we need to use VLSM to subnet it to 6 subnets. Okay, let's see how to do this here. Say our largest one, we said, is 50. So since we have the largest one is 50, the second largest is 30, and then we have 12, and then we have 2, 2, and 2, right? So we're going to start with this one here. first, let's us, I recommend to start with the network IDs for all of those. You start with the network IDs first. Fill it here in the in this table. So 50 users. Which one of those ones here on the top is closer, but not less than 50? So 32 is less than 50. 64 is closer, but it's a little bit extra, but that's fine, right? That's totally fine. So now what we do is we will put 1 here, and then we start filling everything to the left with ones and everything to the right with zeros. So 0, 0, 0, 0, 0, and 0, right? So even though if you want to do this manually, we know that the IP address has 2 portions, right? Network portions, that's the one, and the host portion, which is the zeros. So here we have how many zeros? 1, 2, 3, 4, 5, 6. If you want to do it manually, that's 2 to the power 6 equals 64. So minus 2 equals 62, right? So 62 is enough for 50. Or if you want to just use here the table, you see the last one that you borrowed is 64, which is this one here, 64. So if you do 64 minus 2 equals 62, which is the same as this one. So you can use either way, the formula or use here the table. So now we have our magic number is 64. Magic number is 64. Okay, here we have our IP address 192.168.10.0. Remember, all the time we start from 0. Even in the regular subnet mask, when we do it, you find the magic number, and then we do the increment. We start from 0, and then the next, the magic number, then the plus, plus, plus. That's the increment of that. So here we start from 0, right? So the next network ID will be this, 64. This is the last one here, right? 64. So it will be, let me just copy this here. Will be 64, right? So now we need to find the subnet for the 30. Which one is closer to 30 again from here? Which one is closer to 30 from those here? I would say on those one, the closer one to 30 is this. Even though when we do minus 2, we still have 30, which is enough, right? So 32. What we will do is, because it's 32, so we're going to do 1, and then just 1, 1. And then that's the network part. The host part full with zeros, 0, 0, 0, 0, 0. So now, how many hosts that's we have here? You see here, the last one here is 32. Even you do 32 minus 2, you have 30. Okay, now, what is the magic number? The magic number again is 32 here, 32. So now we're just going to add this one. It goes from 64 to 32. So our next network ID would be 64. Let's do the math. 64 plus 32 equals 96. So this one here will be 96. Okay, so let me just clear this one, and we will start again for the next subnet mask. So we have 12. The next one is 12, this one. So which one here is closer to but not less to 12, right? Not less than 12. 12, 8 is less. 16 is okay, even though when we do 16 minus 2 is 14, which is enough. We have 14 hosts. So that would be 16. So we do here 1, and then we fill everything to the right with zeros, and everything to the left with ones to represent the network site. Okay, so here our magic number is 16. So now again, what we do is, here we stopped at 96. So 96 plus 16. Here we have 112. So that's 112. It would be 112. 112. Here, after this one, so now we're starting doing the point-to-point IP addresses, which this has 2. So now, which one here is closer to 2? 2, that's exactly 2 is not going to work because you do 2 minus 2. So here, 4 minus 2 is 2. So 1 here, and 0 to the right of that. Here you fill it with ones, 1, 1, 1, 1, 1. So again here, the magic number, you have 4. This is 4. How many hosts? This will be 4 minus 2. We'll give you 2. That's 2 hosts, which is 2 IPs. Okay. The magic number is 4. So here we stopped at 112. 112. 112. So 112 plus 4, that will be 116. So the next network ID will be 116. So we have another one, which is this 2 here. Also, it has the same as this one, which is 1 here, and then 0, 0, and then everything here is 1, 1. So, and also the magic number is 4. So the magic number is 4. That's 4 plus 116. You have 220. So the next network ID will be 220. Okay, so now we have all the network IDs. Now let's start the backward from here. The broadcast IPs. Okay, here this one from 0 to 64. From 0 to 64, this is the network ID 0, 64, 96, 112, 116, 220, right? So you minus 1 from the next, this is the first and this is the next network ID, you will have the broadcast IP address for the previous block. So here, this one is 64, so you minus 1, that will be 63, right? So 63, because look here, they are in sequence, 63, 64. So now, the last usable IP, you minus 1 from the broadcast, it will be the last usable IP for this block, so it will be 62, right? The first usable IP, that's you add 1 to the network ID, and then you have the first usable IP there, which is 1, right? So now, let's do this one here, the second one. The second one do the same, right? So here, the next one is 96. You're gonna minus 1 from 96, then you will have the broadcast IP for this 95 for this block. you're going to minus 1 from the broadcast, then you will have the last usable IP, which is 94. The first usable IP, what you are going to do is you are going to add 1 to the network ID, which is, it will be 65. Okay, so let's do the same one here too. So this one here, this is, if you notice, this is 95, it's 96, it's in sequence still, just increment of 1. Okay, 96. The next one is 112, 112. You minus 1 from it, you're going to get the broadcast, so it will be 111, 111, right? Okay, you just do this here to have them all centered. Okay, so here you're going to minus 1, you get the last usable IP, which is 1110. 110. Here, the first usable IP, you're just going to add 1 to this, to 96 here. You're going to get the first usable IP, which is 97. Alright, let's do it for the next one. We're just doing the same thing. Here, the next one is 116. You're going to minus 1 from that. It will be 115. That's the broadcast. Right, that's the broadcast for this block. Let's minus 1 from the broadcast. You get the last usable IP, which is 114. You're going to add 1 to 112. You're going to get the first usable IP, which is 113. You see here, you have 113 and 114, only 2 IP addresses, because 115 is the broadcast. So 220 here, you have then 219, that will be the broadcast. 218 will be the last usable IP, and 117 will be the first usable IP. So here, because it's increment of 4, so this one will be 240. 224. So 223 will be the last. 222 will be the last IP. 223 will be the broadcast, and 221, this will be the first usable IP. Let me just centralize this to be consistent. Okay, so now we have the range of our blocks. Now let's do the just clear this here. Now let's do the subnet mask here for this one here, which is this one, subnet mask. So we borrowed how many bits? Those are only 2 bits. 2 bits, which is 128 plus 64 will be 192. The last octet will be 192, which is that would be 255.255.255.192. How do I get 192? That is the okay. I don't know how to clear that. Anyway. This 192, that's 128 plus 64. Now for the second one, the second one, which is this one here, it has 1 1 1, which is 3 ones. That's slash 27. 1 to here 128 plus 64 plus 32, which it would be 224. So that would be 224. If I use this one here, that would be slash 224. 255.255.255.224. Here, because we borrowed 2 bits, that would be slash 26, because 24, 25, 26. Here we borrowed 3 bits, which is this one, and this one. So it will be slash 27. And now let's do this one here. Let's do the purple. So 1 2 3 4, right? So, and now this one here is 128 plus 64 plus 32. This is 224 plus 16. It will be 240. So those are 240. And we borrowed how many bits? 1 1 2 3 4. So this one will be slash 28. And will be 240 because we borrowed 4 bits. So that's 128 plus 64 plus 32 plus 16 is 248. Now let's move to the next one. Let me use the I didn't use this one. Okay. 1 2 3 4 5 6. So we used we borrowed 6 bits. So now if we added 128 to 64 to 32 to 16 to 8 to 4, we'll find it 252. So this will be here 252. And because there are how many bits are borrowed? 1 2 3 4 5 6. So 6 plus 24, this one is slash 30. So the next one here, it will be let me use the yellow. How many bits we borrowed? 1 2 3 4 5 6 again, 6 again here. So those will be also slash 30, 6 bits, 30. And the subnet mask will be the same, and it will be the same here for the last one. If we need to fill this, it will be 0 0. Oops, so it's from this side. 1 1 1 1 1 1 0 0. So now we do have a variable length subnet mask. As we see here, we have this one, it goes from 0 to 63. 63 is not usable, and 0 is not also usable. That's why not usable. That's why we do -2. And the usable IPs, it goes from 1 to 62. So we have 62 usable IPs, even though we required only 50. And here from 65 to 94. 95 is a broadcast. Here we have 30 hosts, and here we have 14. 97 to 110. 111 is a broadcast, and that's all. Now I believe that's it. I hope this has been informative, and I would like to thank you for viewing.